Welcome to an exclusive webinar. The CATIA MBSE R&D team has prepared a special session to share Dassault Systèmes plans for SysML v2. I am Gitana Strazdauske, and my colleagues today will explore how SysML v2 is seamlessly integrated into our CATIA Magic Magic product line, providing key insights into the transition from SysML v1. The speakers of the webinar are the real experts in their fields: Andrius Armonas, Nerijus Jankevičius, and Tomas Viliniškis. We all are very happy to have them here. During and after the presentation, you will be able to ask questions in the Q&A section. The speakers will answer them at the end of the webinar. The webinar is recorded. We will share the file with the attendees. The recording will not be shared publicly. So that's it for the introduction. Enjoy the webinar, and please, Andrew, you can start.
Hello, everyone, and let me share my screen, and thanks for the introduction, Gitana. All right, so just like Gitana mentioned, please feel free to post any questions you have in the Q&A panel in the application, okay? And most of these questions will be answered at the end of the session, but we'll try to also answer those questions as we go, all right? So as much as we can. If some questions will not be answered on time today, so we'll try to do that next week. And then we'll post some notes with some answers. So welcome again to this, I would say, first webinar this year. There will be a series of those with the updates. And I'm Andrius Armonas. I am a long-time Magic employee before the acquisition, now part of Dassault Systèmes. And my key responsibilities are around SysML v1 and v2. Specifically now, I'm leading the SysML v2 development in here. And I'm also the MagicDraw product manager. So MagicDraw is kind of a platform used for other modeling solutions we have, which are Cameo Systems Modeler, Cameo Enterprise Architecture, and I'm sure most of you are using those products. So MagicDraw is like a platform for those. I'm also our representative, Dassault Systèmes representative at the OMG, specifically the SysML v2 and thermal working groups, and coordinating our feedback, that we give to the OMG. Also, I am the chair of the OMG RAML working group, which is focusing mostly on the safety, reliability, and cybersecurity aspects. Specifically, we are extending SysML v1. And now we are actually focusing on extending SysML v2 of these abilities, if you will. So this is the agenda for today. We'll start with simply looking at what OMG is doing in terms of SysML v2 standardization. Then I will mostly focus on the modeling side. So as you know, we are building a SysML v2 product, and I will be demoing how it looks in the actual tool. And I have two colleagues today, Nerijus and Tomas, with me. They are great experts in the things we are doing for many years, right? They've been there for many years, and especially Nerijus, he has been there since the beginning. I'm also 15 plus years with the company. So he will be giving an overview of how we support simulation of SysML v2 models, which we call evaluation these days. Right, and Tomas will be covering how we support SysML v2 standard APIs, as well as collaboration aspects. So let's start. So, well, if somebody's thinking about MBSE or adopting MBSE tools nowadays, well, they are looking for SysML tools most likely for doing MBSE, and the de facto tool for doing that today is Cameo, Magic, and Magic Portfolio. We have different names, right, for essentially the same thing. But that's what the current status is. And the same team, not some other team, but the same team is actually now building a SysML v2 solution, including myself and my colleagues on this call. And if you want to access gain access to what we're building, early access, right? So there are two ways to do that. One is through the early access program. We call it EAP, if you want to co-develop with us, right? So if you want to influence our roadmap, if you want exclusive access to our R&D people, this is where you need to go. Now, if you just want to learn SysML v2 language or understand where we are going, so there's another program called Early Experience Program. That's a very light process to join this program, and I really encourage you to do so. And again, it's super easy, and you just gain access to the products we have today. Of course, they are in early phase, if you will, right? But still pretty impressive. And the generally available release of our products will be at the end of the year, specifically November. And we will be releasing 2026 X release, which will include official support of SysML v2 standard for everyone. Now, how do you engage? On the left side of the slide, you see how do you engage into the early experience program and early access program. So for the EAP, you just email myself, right? You can see my email here, and we'll sort it out. Now for the early experience program, there's a general email. Send your contacts. Tell us that you want to join the program. Preferably, you should make sure you have valid 2024X licenses, and also ideally install 2024X Refresh 2 before emailing. That will make the process easier, right, and smoother. Now, if you want to receive updates on where we are in terms of SysML v2 implementation throughout this year, we'll be posting a lot of videos this year on our YouTube channel. We were posting a lot of them on SysML v1. Now we will be doing so on SysML v2. So yeah, subscribe to our YouTube channel. Also connect with me on LinkedIn. I have I usually post some notes, especially insider information when it's possible, and I will be continuing doing so this year. Now, where we are in terms of adoption. So I would say that a lot of our customers already adopted and tried SysML v2 implementation. They're adopting their methodologies. So I would say the majority of them are already one way or another are doing that. But also, we are kind of proud that the key thought leaders in the industry are choosing our implementation as well. Like, for example, Sandy Friedenthal, who is the father of SysML v1 and v2, he's using our implementation. Also, other people like Aurelius Morkevich is leading the UIF v1 and v2 development. Gene Shreves, who is actually building AADL extension for SysML v2. Also, Tim Wilkins, who is a very famous book author. All of them are using our implementation, and we are getting a lot of feedback, great feedback, how they like it. So I encourage all of you to join EAP or EEP programs as soon as possible, and to join these guys as well. Our experience, the great projects we built. Now, in this slide, I tried to put together some information on where OMG is in terms of standardization and where we are, right? So at the top of the slide, you can see that while the specification of SysML v2 is not released yet, that the final submission should happen in something like 5 to 6 weeks from now. But the official publication might happen likely in September, right? So this is still in progress, right? And there are still issues being solved, and the specification is still evolving. So that's why we cannot release the product. We cannot release the product before the spec is ironed out, right? So and that's just like I mentioned, will happen at the end of the year. Now, before we go into the demos, I know that many people in today's audience probably haven't heard much about SysML v2, and you haven't tried tools. So let me just give you a brief introduction into the SysML v2 and the differences from SysML v1. Okay. So this slide is actually coming from Sandy Friedenthal, so credits to him, but it's important because it basically lists the goals of SysML v2. And one of the key goals is that, well, the language is more precise and expressive now, and that's very much true. You can do a lot more things with it. But that means that if you are an advanced user, likely you will have to learn a bit more, right? That's natural. Another thing, the second bullet point is the consistency of the language, right? So the language is really much more consistent. Well, what does that mean? Well, it means that if you learn in practice, you know, how to model parts of the system, the structure of the system, likely to model the behaviors of the system will be, well, to learn that will be quite easy, okay? Because the entire language is designed by the same patterns. So that's a good thing. Another thing is interoperability with other engineering models and tools. Of course, there is a significant step forward here because we have a standardized API now. Thomas will be presenting it, and that's a significant difference from SysML v1. And this will enable ecosystem, which means that somebody like a partner can write a plugin or an extension to our product, and that extension is likely to work with another vendor software without adjustments. Again, likely. So we'll see how that goes, but there is a strong belief that there is a reason to believe it, right? Another thing is usability by model developers and users. Well, that's very much true, especially if you are I would say, inexperienced user. So for these kinds of users, and especially for simple modeling, the language is really simpler to use and more natural to use. Now, when it comes to advanced users, it definitely, you have to learn a bit more to understand the concepts behind it. As for the extensibility, the language is very much extendable. And actually, there are significant differences from v1 there. So if you had extensions for SysML v1, when moving to SysML v2, you have to completely redesign those extensions because now we have libraries, which are the key way to extend the language, not stereotypes. Now, we have something, of course, like stereotypes in SysML v2, which is called metadata, but you shouldn't be using that much, right? You should focus mostly on libraries and have very light metadata for stereotypes, if you will, in SysML v2. So that's why you just cannot move the extensions you have in v1 to v2. That wouldn't be right. And the last thing is the transition from v1 to v2. So there is a transition specification, transformation specification from v1 to v2, which we support. And that will be part of 26X release. All right, so on this slide, you see the key differences from v1. One is that there is no longer UML in there. So we have now another meta model called kernel, and SysML is extending from that meta model. So a lot of changes basically in the language just because of that. Now, if we talk about visualization options, we have the graphical visualization option or representation of the model, the tabular and the textual. So graphical is like boxes and lines. Tabular, well, tables, you always had as our customers, tables in our product, and you're very used to that. So not that much to talk about, right? So our customers always had it. Textual, well, our customers never had it, and we implemented. We do have support for textual syntax, 100% compliance to the standard today. But one important aspect here is to realize that these are just visualizations of your model. The model is still there. The model is still there. It's not that the model is text or the model is graphical or the model is tabular. These are just alternative ways to represent data in the model, okay? So that's very important to understand. So the model is still there. The model is versioned, not the text is versioned. The model is versioned. Right, that is important. And the last thing is standardized API. Again, that's a huge enabler, I think, for the ecosystem. And we, as Dassault Systems, we support it 100% as well. So this slide represents the language architecture. Just like I mentioned, there's not just SysML v2 meta model at the top of the slide, but also you can see the kernel, which is another meta model. So there are two specifications, not one. And the kernel meta model is independent of the domain, right? So it can be used in some other domains for building other languages in the future. By the way, UIF specification version 2 is extending from SysML v2 meta model, not kernel, just for you to know. Now, if you look at the high level, in terms of what capabilities the language has, that's the slide you would need. And yes, the language allows you to model requirements and the behavior of the system, structure of the system, and analyze the system verification cases. And it allows for views and viewpoints modeling. Well, you would say not that much different from what we could do in V1. Well, if you look at the high level view, yes, that's true. But now if you would try to understand in detail the differences, there's a lot to cover, right? And I tried to list the functional areas of the language in this one slide. And green areas display basically the functional areas of the language where differences are significant. So even on the left, at the beginning of the list, you can see the part decomposition. So there are significant differences. Now parts can own other parts, which it could not do in V1, right? There's a completely different interconnections mechanism, right? The way flows work. Also variability, item number 6. That's what we call PLE, product line engineering. All tool vendors had to build their own extensions in a very custom way to support product line engineering and variability. Now we have a standard way to do that. Again, a huge improvement. As for the instance specifications, we had just one element, instance specifications to model real-life objects, right? In V1, and now this concept has become super powerful with introduction of individuals, time slices, and snapshots. That became much more powerful now. Now, as for the line item 13, you can see that it's called expressions. There is a standard language for querying the model. Again, standard language. We had structured expressions in V1, which we built as a custom extension, which was super popular and is still very popular and very nice to use. A lot of compliments from customers. And now similar thing is called expressions. Whether or not we'll need a specialized user interfaces to be able for users to actually use it, that's another question. Still, it's a kind of it's a huge improvement. Also, it's a standardized querying language, and Thomas and Marius will talk a lot about this today. As for the analysis cases and verification cases, we always get it again as a custom extension in Cameo for doing trade studies and covering related use cases. Now it's part of the specification. Again, this is part of our contribution to the standard, right? And then maybe the last things is the language extensions, which I already covered to some degree, I guess, right? Huge changes there. Just for you to know, the focus is on libraries. If you want to build extensions in SysML v2 model, you have to focus on libraries and build very light metadata. Now, for those who never seen SysML v2, I have just put several screenshots for you just to get a feel of what it looks like. So if you see the 1A is the representation of the model in text, right? Of the same model, which is represented in graphical syntax on the right-hand side as 1B. When it comes to graphical syntax, you still see boxes and lines, and you can recognize probably this guy is a part, that's a port, maybe that's an interconnection. So something really familiar, something that you've seen already probably in V1. As for the left side, the same thing. Again, the same model can be represented as text. It's also possible. Whether or not you want to use one versus the other, it's up to you. Our implementation supports both. You can use both at the same time or interchangeably, or just one of these. So it's up to you, and it's up to your methodology. On the right-hand side, there's another example of state machine represented in text. Again, our experience is such that when it comes to interconnections, it's easier to manage that in graphical representation. You see here, it's really easy to understand what connects to what. If you look at the text, well, it's just a bunch of text here. Not that easy, but when it comes to putting together quickly a structure of the system, the textual is pretty nice. Okay, so what's part of 26X, which is the GA release, generally available release of the SysML v2 implementation, available to everyone in November at the end of the year. Well, just like I mentioned, we do support textual and graphical syntax, right? And probably we are the only solution today on the market supporting both, where you can model in graphical and textual, and these views are in sync, right? So that we are the only one doing it. Then model exchange is really important, right? Because there are suppliers and OEMs and all they need to exchange data. So we do still support MDZIP format, which is the de facto standard for exchanging models, especially in American DoD. We also support the .SysML way of format of exchanging models. So it's basically the .SysML files, they just contain the textual representation of the model, right? This piece, this text goes into this file and you can export it to another tool, or you can import it back into Cameo. As for the simulation, so Nereus will cover that today. As for the extensibility, so we are strong believer, and as you know, our DSL support is so good in current implementation in Cameo and heavily used, and we are definitely working on this for SysML v2. We have a lot to show, but not today. So everything and anything you were able to do in v1 solution, actually more things you will be able to do in SysML v2 in time. As for the APIs, Thomas again will be covering that today. As for the storage, you have two options. If you are using Dassault Systèmes 3D Experience platform, you can store models, SysML v2 models in that platform. If you don't use that platform, you can store those models into Teamwork Cloud, right? So it's up to you. It's your choice. And also, in the meantime, we are working on other things, right? So our customers, of course, are interested in the web availability of our products, and we are heavily working on that. And I will show a couple of demos in minutes. Also, we have a lot done in terms of AI. A lot of things are going on, and definitely very exciting times are coming. As well as discipline integration. As you can imagine, SysML and MBSE is about discipline integration. And of course, it's critical to have discipline integrations ready and available, and that's our focus as well. All right, so now let's go to the demo side of things. So how do you create a SysML v2 project? Well, that's very simple, just like you do with SysML v1 projects. You go to Cameo, you choose the new project creation dialog, and in here you pick SysML v2 flavor of the project, not SysML v1, and boom, you have the project created. And then in here, I already built some kind of a demo, right? But before running it, I will just quickly explain that the differences are vast, right? You can quickly notice that a part here has another part that was not allowed in SysML v1. And you can notice that parts can have ports, which was not allowed in v1. Then you see actions, which are displayed in the same diagram as parts, a structure of your system. It was not allowed in SysML v1, right? And many wanted it. Actions can have other actions, right? And parts can perform actions, right? So you can see that this part is performing this action, which is called produce a direct light, which is exactly this action. Really, lots of differences. I could go on and on and on, but that's not the focus of today. Instead of that, I will just show how we implement and support the language. And you can see here the graphical representation of my model. And in here, I'm creating some ports, right? Just like in SysML v1, right? But at any time, and at any given time, I can switch to the textual view, right? Just go ahead and continue my modeling in the textual editor here. And it's a really nice environment, very similar to the one developers have, those who write Java and some other code, right? In here, I am modeling a port definition. If you want to understand what it is, it's like interface block in old terminology, right? So modeling it in text, and I will use this port definition or interface block, if you will, to type a port, right? So I'm completing that definition. And now you can see I'm using, again, auto-completion is also supported. So I'm using auto-completion to just set a type for my port. And then I can navigate easily to the referenced element, which is in this case, it's a port definition. Or I can see here some other referenced elements. Again, navigation is supported. Or I can simply preview my changes by peeking, right? So I just can peek this change. I don't need to lose my focus. I don't need to go to other area of my editor just to look at the definition. And at any given point in time, I can switch back to the graphical view and continue modeling in the graphical view. Isn't it that nice, right? And again, switch back to textual. Just like I mentioned, all those views, these are just views. My model is on the left side. You can see here the model. That's my meat, right? That's what the system description is. And in here, these are just representations. That's why I can easily switch between these two or use one or the other, and probably maybe sometimes never used actually if I don't know how to use it, right? At any rate, just like I mentioned, it's really important that we want to move our products on the web. And since that's a good opportunity of SysML v2 to rewrite a lot of code, we had all this new code is web enabled. So in here, you can see the current version. Again, it's not accessible to end users, but it's a web version of Cameo. In this specific case, I'm showing a reader, which just allows you to read models, but you can see that the experience is pretty much the same that you have in Cameo, the experience that everyone loves, right? So, and in here you can open even the tables on the web. These same tables are, by the way, available in Cameo implementation. There's navigation back to the model from the table, and different kinds of tables are supported, and these are fully customizable. And the standard now defines how you should customize these views. And you can open these models, not just in tables, but in the textual editor. The one you've seen in Cameo, the same editor is available on the web, right? So if you know this syntax and you prefer it, you can explore your model through this, through these views. And of course, the last thing, but really important is the graphical views, right? So of course, on the web, we do support graphical views as well. They are nicely rendered. Yeah, and of course, if you need to explore the model in more detail, there is a specification panel, as we call it, right? And it's a very rich component. You just double click on an element on the right-hand side, you can see the specification of the element. For example, what are the attributes? What are the ports, including inherited information? What are the performed actions? A lot of things. And there is a special navigation implemented where you can, for example, navigate from a port usage to port definition, right? And if you want to see all of it, right, all the information about the element, you can go to the specification dialog here, which shows all the meta properties of all values. So this is useful when you need to write those expressions that you mentioned, right? So this is exactly useful for these kinds of purposes, but you don't use it that often. All right, and the last demo I have is on editing, right? So it's not just the viewing that is important, but at some point we will be releasing the editor. And again, the experience will be very similar on the web as we have in Cameo. So in here, again, I'm showing a very early version. Again, I don't think we'll be releasing it this year, but you can already see that it's really looks very similar to what you have in Cameo, because most of this new code is exactly reusable on the web. And then here I'm showing how I'm creating parts and connecting those two parts using an interface. Before that, of course, I need to create ports because interfaces connect ports. Right, and we are moving a lot of functionality from Cameo onto the web, including automatic layout, right, as well as simulation capabilities. So all of this is coming actually into this environment as well. All right, and the last thing is the transition strategy from SysML v1 to v2. So very important aspect on our side is that you do it at your own pace. We know that there are thousands and thousands of projects that are being developed in SysML v1, and many of them, they need to be developed in SysML v1, and they should never migrate to v2 at all. If that's a maintenance project, keep maintaining it in v1. We will support this v1 solution as much as possible for many, many years. So you are safe to use the v1 solution for as long as you need. And for new projects, of course, you have to consider whether to use v1 versus v2. For some other old projects, you have to make a decision when you want to move to v2. It's, again, your choice. We will never force that. And it will be, again, support is of v1 versus v2 is on per project basis. So one project in the same repository in Teamwork Cloud can be in v1 format. The other can be in v2 format. It's up to you to choose. And we will support the transformation specification. And you can just automatically transform your v1 models to v2. But after transformation, please bear in mind that a post-processing needs to be done. If you want to basically, you have to refactor your model to make full use of SysML v2 capability. As for the APIs, we do support standard APIs, but we will also keep supporting standard Teamwork Cloud APIs, which are our APIs, right? Which you always had. We will support them in v2 with v2 models as well. As for simulation, we will support all use cases we support for v1 and more, including usability. Usability is core of our solution, and we are hearing from customers already that our SysML v2 solution is like super nice in terms of usability as well. All right, so that's it on my end. Nerijus, over to you.
Okay, hello. Let me share my screen now. Can you see my slide in full screen?
Yep.
Okay. So let's move. I'm Nerijus. I'm a product manager here, working for the last 2 centuries. And on that tool, and also I was contributing to the UML and SysML language specifications and precise semantics of UML and SysML implemented, and I was leading the SysML v1 implementation as a Cameo systems modeler, also Cameo simulation toolkit. And currently I'm focusing on SysML v2 execution semantics. So as I'm using Andrew's slide, so I'm going to talk about this part, the model execution. But as today we only have 20 minutes for this demo, so I'm mostly will talk about the expression language evaluation or symbolic expression language evaluation. As Anders already mentioned, this SysML v2 comes with the standard textual syntax and standard expression language, which was a big lack in SysML v1. So, for example, if you look at this slide coming from a submission team and Ed Seidowitz, so if you look at the bottom, let's say we want to calculate what's the vehicle total mass. If you look at the model, the total mass can reference other 2 attributes, and it has a plus operation here. If we're going to evaluate empty mass, we see that empty mass is referencing other attributes, and it's calling this sum function, and it must resolve into all the subparts and the subpart masses, and so on. So basically, you have to traverse all those references, traverse the expression tree, call library functions. So keep in mind all the multiplicities, the instantiation of the parts, what inheritance you have. So keep in mind inheritance, redefinition, subsetting, and so on, and resolve those initial values and derived other values, and at the end you have a number. Basically, that's the idea. And I actually want to jump to the tool and show you those concepts. Okay. Okay, I would like to hide my floating panel. Okay, So I want to start from SysML v1. So via in Cameo, it's a 24 refresh 3 release candidate. And the nice thing is, as Andrew said, you know, the continuity. So you can open SysML v1 or SysML v2 in the same environment, and you can switch between projects. So I'm starting from SysML v1 because I want to show you this example and what was needed to implement this in v1. So that's a classic example of the spacecraft coming from a systems engineering training one-on-one from NASA. Basically, it shows the structure of the spacecraft and the idea that they always have a very strict mass budgets. So
Nereus, I think you're not showing your screen. We just see the slides, but not sure if you're
okay,
showing the, want to show the tool.
Okay, maybe I don't know why not. Okay, let me stop sharing and reshare the screen again, because I'm sharing the desktop.
Now we see the Cameo.
Okay. So you see the spacecraft structure and all and substructures of subsystems and components, and that's typical problem in aerospace, because you have a very limited a rocket thrust, and you know what's the maximum mass. So you allocate the mass on the total component. You then maybe allocate less to subsystems and so on. So you have allocated mass. Then when you're building the design and you have actual physical implementation of those components, you can estimate or calculate the estimated mass. And the main rule is that the estimated mass must be less than allocated, especially for the top level spacecraft. Otherwise, it would not fit onto the rocket, right? So that's the problem. So how would you model this in V1? And that's actually our example. So if you are a Cameo user, you probably know this example, using it a lot. So in V1, you have to define those mass attributes somewhere. So you have to invent some pattern, and we call that component. And if I go into it, we use a complicated parametric diagram. You probably would not understand what it does. It just have that rule that estimated mass is less than allocated, and the mass, and we have a sub of the sum of subcomponents, and this is how it looks in V1. So it was really complicated. So you model this, you hide it. If it works, it's fine, but it's not that easy to read. And also the problem is that all those mathematical expressions are actually simple strings, because the SysML v1 or UML has no expression language at all. So you have to use scripting language or interpret it as a standard MATLAB-like mathematical language. So it's a real problematic. And if you change those names, you cannot update because you have no actual references to that. So that's V1. And and also, if you want to assign those mass attributes, you don't have those in blocks because you inherit them. So you have to create an instance model. You see the instance table at the bottom. So you can enter some initial values. Then you run the simulation, you calculate the results, and you can do requirement verification. So this is how it looks in V1. Now, you see how easily you can switch from V1. I'm switching to V2 version of this model, and I'll show you some advantages, how, and you can decide is it easier or not in V2. So I'm switching to the textual language. So first of all, we define the massive thing. So the thing which has allocated mass and estimated mass attributes. And the margin is the difference between those two. And you see immediately we have equal and we have a references. So if basically that's a hyperlink. I hold Control and click the mouse. I jump directly into the reference. So I have those two attributes referenced. I don't need any parametric diagram and parameterize those and use connectors for the binding. I can do this in a textual readable expression language. Then I have a requirement. And the nice thing is that those requirements are more formalized in V2. So requirements have subject. So I can say that this is a requirement for any massive thing. I call it thing as a subject. And then I can express, so requirement has a formal constraint. So I say that thing, I am referencing the definition of the thing. So the estimated mass less than allocated. And then I can use it. So requirement can be used as, so you say satisfy requirement, it creates a requirement usage. And you can use it in any context. So you can say that it must be satisfied by, in this case, I own it directly, so it's satisfied by this, but you can actually say that it's satisfied by some internal part of my system. Okay, so that's the definition of the masses. Now let's construct more complicated structure. So let's say we have composite thing, which is a massive thing, and it has subcomponents. So subcomponents are massive things, and the total estimated mass is sum of subcomponents. So look how easy it is to do the math. We don't need any complicated patterns for the subsetting. It's just a standard library function. So if I select this in the containment tree, we don't have a kernel editor. It's coming from kernel. Actually, Russell was asking already in the Q&A window, do we have a kernel? So we don't have a textual editor for kernel, but you can reference those functions coming from the library. So sum is a standard function, and we can easily do and say, use the dot notation and say, okay, let's do the sum of all subcomponent MEs, the estimate masses. Okay, now the structure itself is very unique and convenient. In V2, you can own parts inside parts. That's another question in the chat window. So I don't need to define and use those block definitions. I just can construct the structure on the fly. So for example, here, I just defined the spacecraft with 2 subparts because I didn't know at the beginning that I'm going to have more. And I can easily create another, like a subtype of the spacecraft, and on the fly add another things and redefine telecom and add 2 additional parts inside. I can easily assign the values using syntax like this. It redefines my, actually it was empty. So basically I'm assigning the initial default values for those attributes. And the entire, basically that's entire block model and an instance model at the same time, if you compare to V1. And that's it. That's the entire model. I zoomed in the regular font, it fits into one screen. And as Andrew said, this is a textual representation, not the model itself. Model is in the browser. So we have model elements. This text is actually parsed into the things. So if I look at what is the margin and I go into the containment tree, you see that it's not just a text, MA minus ME. It actually parses into a huge expression tree, having actual references to features and pointing to library functions or operators. So it's just a view, and then we can create diagrams and represent the model. So just use typical display parts recursively, and you can just display the entire spacecraft. And we have a new engine to actually interpret that language and calculate things. So we have this function button here. If I press it, all the attributes are calculated, all those expressions are traversed, and we have the values. And you see the coloring, green and red coloring. If green is everything is fine. If it's red, you can read a tooltip and see what requirement was failed. And also you see that icon. So in case you have some compartments suppressed, you cannot see what exactly fails. So you can read that the failures are in mass requirement. If you go up, that's a yellow, which means yellow annotation means indirect failure. So it says that nothing is failing inside the propulsion, but deeper in the thruster, we have a failure. So we can navigate and read those. So even the thruster fails, but the total margin is still 35. So the system itself is not failing, it's green. So it's good to go. But you can talk to the thruster team, to fix. So this is a simplified model. This ME is entered in my model. In the real life, it would have a reference to maybe CAD model with the bill of materials. So you could calculate what metals you use, what is the mass of that physical model, and you would somehow read that value. If you have an integration and connected tools, you would read that value into the model. I'm using it hard-coded here just for the demonstration. Okay, so let's say I'm changing. So the nice thing is that we allow to play and do what-if analysis. So if you change it to 55 here, I have another failure, and even my total mass fails for the spacecraft. I have margin -1. It's not big. If I change this one to 28, it's green, and the total system is green. Only telecom is failing now. So we can play with those values. And so basically the goal is to, we are not changing the model, we're playing with runtime values. So basically you instantiate the model, you run that expression evaluation engine, and we have those values temporary. So until you clear the values, you have those and you can change and play and recalculate. You're not touching the actual model and not changing those. So of course, we'll have a saving back to the model. It's not implemented yet. So you will be able to set those back to the model or create maybe new snapshot. There's a snapshot concept in SysML v2, or you can export to external CSV file. So let's select attributes as columns, export, click on that reference. I hope you see my another application, and the spreadsheet is here. So we have all those attributes. That's a roll-up table. You see all components, subcomponents, and allocated estimated mass, and the margin, and the requirement verification. Okay. Clear values. Now let's jump to a more complicated example. Just, it looks more complicated because I have more expressions to show. So that's a vehicle example. I have a couple of requirements. Those requirements are more complicated. So, but also shows nice concept that you can also define attributes or parameters in requirements. And also the subject can be, you can use dot notation, and subject could point to deep nested subsystem. And those, you see those expressions are more complicated. You have reference to nested parts. The dot notation is natively supported. I have a structure of the vehicle. I have a wheel structure, brakes, and let's say there is a brake torque attribute, and it's a pretty long chain of expressions if you try to calculate. So what's nice, we have another tool. So we can do this from textual editor. So let's say I have no diagrams. There is a function button here, the evaluation button. I click it. It opens the evaluation panel. And see, this attribute is evaluated. So you can click and see what's the value, what's the estimated value based on some default initial values from my model. And we also have input field. Okay, I see the zoom icon. I cannot type here, but okay, let's say I'm selecting the brake in my browser, and we have a button to use it as a context. So I don't need to type fully qualified names with the packages. I can resolve the names inside my brakes now. And let's say I type, I hope you see my line, heat, it's more than 50. It says false. So what is the heat? So you can use this line to do any kind of manipulations and expression evaluation. So you enter that string, we would parse that string into expression, evaluate. Okay, there are more interesting concepts here. Like if you have many requirements, you can group them and create test cases or verification cases. So this part in the model is a verification case, and the objective is to check two requirements. So I want to verify stopping distance requirement and verify the brake heating requirement. And only if those two requirements are true, I can say that I have safe stopping. So that's an example. So basically the main one is true only when all nested requirements are true. So actually you can create that verdict. So that's the default interpretation, but you can create more sophisticated rules again using the expression language. So if I show this in the diagram, let's close that window. I have vehicle structure, a couple of parts. I don't want to show everything, but just a couple of attributes. If I evaluate, You see all the attributes evaluated. I have all the values and the stopping distance estimation. My verification is shown as a box here. You see those two requirements, objectives, satisfied, and my total verification passed. But let's fake that I have one failing requirement, which is life expectancy. I don't care. It's not included into verification. But if I fake the stopping distance failure, let's say my mass of vehicle is 2 tons, is too heavy to stop on, and I have a failure, requirement failed, and the verification automatically failed because one requirement is failing. Okay. Another concept I want to show is the trade studies. So what is the trade study? In system engineering, trade study is evaluation of a couple of alternative designs trying to find the best value of something. So you can define this using a standard trade study concept in SysML v2. If I click and go to definition, you see that it opens the standard SysML library. Trade study is defined there. So it's part of the language. So you can create your own trade study. In this case, I want to do stopping distance trade study. So my evaluation function would say that I'm looking for the vehicle stopping distance. My list of alternatives defined like this, just a list of A, B, C, D, and those A, B, C, Ds are defined here as vehicle A with redefined braking subsystem parameters. So I have 4 different alternatives or configurations. And the objective is maximize. Oh, sorry. Minimize for stopping distance. So I want minimum stopping distance. And there is another trade study defined here with the same configurations, but I want to maximize a life expectancy of the braking system. So this is how you define trade studies. It's pretty easy. In this case, I have a fixed list of alternatives, but you can call a function, a custom defined function, and basically you can do a parameter sweep or synthesize those. So it's not necessarily fixed version. The language allows you to do loops, iterations. You can do that. And when I mean functions, I forgot to show you that you can not only reference the standard functions, but also define your own. So let's say in this case, area is my own. If I click and navigate, it's a calc def. It's called in SysML v2, the functions, those custom functions are called calcs, and you can do whatever you want and return the parameterized past parameters and get the result. So for trade studies, if I show this in diagram, I have those 4 vehicle configurations. I click evaluate button, and I see, if you look at, I can show the trade studies as boxes. So those definitions, actually usages of the trade study coming from model. And you see, we're showing the annotation. The result of trade study is vehicle C. So stopping distance winner is vehicle C, and the value is here, 31. A brake life expectancy winner, vehicle A. Even some requirement is failing. So, and to show that it's dynamic, let's say change the fake the stopping distance of vehicle A. So if I would change the mass again, it's easiest. Make it very light. So it's green now, and you see it's instantly we evaluated those all 4 configurations, and the winner is vehicle A now. So that's an example with some fixed list, but you can run a lot of those dynamically. Okay. So I'm going back to my slides. Just to summarize, we can call custom and library functions, verify requirements, do rollups, trade studies, analysis cases, verification cases, and we have some UI as a console, diagram annotations, and CSV export. But that's not all. The surprise is that one last thing is the REST API. So it's already designed to be server-side ready. So you can run that analysis on the server side and use REST API We have an endpoint coming with the bunch of other, and the standard SysML v2 REST API. Thomas is going to talk about this. And evaluate is one of them, so you can pass any expression and get evaluation results. So just a 1-minute demo. In the Swagger interface, you just type any expression you want to evaluate on the server model. And in this case, you can even use the meta keyword, which allows you to access meta types and meta attributes. It becomes like a query language. I'm asking what are the parts of the vehicle, because I don't know what to evaluate, let's say. So it's like a query language, but also the same standard. Okay, sorry, it jumped. Okay, those results are here. You see, it listed all the attributes and those names. So I can traverse the model using the expression language queries. And I see this, there's another attribute. Yeah, those videos are always complicated when full screen. So I see the name, I copy the name of attribute, going back, and then I can evaluate that attribute and getting a result as a response. So this API allows you to integrate any third-party tools, and we also have a small Python client, so you can just, like, this is example of Jupyter environment. You can just log into the Teamwork Cloud, and then let's say list the projects. Thomas is going to talk about this. You have project ID, and set that ID and evaluate anything you like, any expression in the context of that project. So you can do analysis, you can integrate tools, you have access from the Python, do pre-processing, post-processing, plotting, anything you like, or you can just extract those default values from the model using very simple expressions. Okay. That's it. And Thomas, the stage is yours. I will look at the questions and try to answer your...
Alrighty, thank you, Nerijus. Thank you, Andres. Let me quickly share my slides. So hopefully the screen is up. Alrighty, so server side of things. First of all, my name is Tomas Vileniškis, also known as Mr. Teamwork Cloud, hence I'm the Teamwork Cloud product manager. So I've been working on the product pretty much on its vision and its execution for more than 7 years. Additionally, I'm highly involved, I was involved and still involved in OMG activities, especially when developing SysML v2 standard API specification. So I'll talk about that a little bit in my presentation as well. And I'm also recently involved in other OMG activity that is called Reusable Assets RFC. So Andrius and Nerijus actually did a great job showing all of these fancy, flashy SysML v2 things, all of these functionalities at the client side. But eventually, at the end of the day, the models that those guys produced, well, they need to be persisted, right? And persisted preferably in a scalable and performant way. So when we started initially thinking about SysML v2 persistency and collaboration, our mindset pretty much focused around 5 main items that you see on the screen. First of all, is scalability and performance. Inevitably, SysML v2 meta model, SysML v2 specifics, it has a lot of challenges when it comes to scalability and performance. So we are trying to tackle those challenges very successfully, I would say, and we treat scalability and performance as our priority number 1, just as was the case with SysML v1 implementation. Then it's pretty much unification and consistency. As you can see on the screen, today we have 3 separate environments for model persistency / collaboration. So it's the de facto MBSE repository standard in the industry, Teamwork Cloud. More or less everybody knows that. Then we have the new kid on the block for the Experience platform, which not only offers MBSE collaboration services, but pretty much an end-to-end fully traceable digital engineering solution. And last but not least, we have local model files, right? People not always work on the server. People also are modeling locally on their computers. Agile collaboration, internal and external one. So when modeling huge systems, it's pretty much impossible to stay within the boundaries of one single organization. Hence the reason we have this term of internal and external collaboration. And our goal with SysML v2 effort is to make that collaboration as agile as possible. How we approach that, I'm going to unveil in the upcoming slides. Software engineering inspired model management principles. Sometimes when you start working on a new thing, it's not worth reinventing the wheel. It's worth taking a look back how things are being approached in other disciplines. And software engineering is actually a discipline that has solved a lot of challenges that MBSE is currently facing. Therefore, we are paying more and more attention into how things are being done in software engineering, especially when it comes to model management principles. Last but not least, we have openness for integration. So our platforms has been open for integrations from day one. So this is all about APIs, proprietary APIs, and from now on, standard APIs on top of that. One of the first groundbreaking things, one of the biggest changes that we're introducing with SysML v2 is a notion of a local model repository. Why would one need that? So one of the biggest challenges previously was that we were lacking unification and consistency when working between server projects and local ones. From now on, it doesn't matter if you're going to be checking out models from 3D Experience platform, from Teamwork Cloud, or you will be working with local MD-zips and other local file format representations. You will be modeling on a local model repository, not on files in the case of local persistency. What does that mean? That means that out of the box, you will get capabilities that are native, that used to be native only to the server-side solutions. That means that locally, you will be able to create branches. Locally, you will be able to create versions of the model, etc. Now, talking about local model files, we are having the following strategy of mainly trying to push a new format that is called szip. So this new format has been introduced in SysML v1 as well. This is pretty much highly reflecting our native persistency serialization principles in a local file format with one single goal: to make model exchanges, imports, exports blazingly fast. However, that does not mean that MD-zip, industry known extension, is going away. By no means, no. It stays. However, for SysML v2 models, the internals of MD-zip will change slightly just to make it more close to the standard ways that SysML v2 models are being serialized in other formats like KPAR files, for example. Talking about unification, one of the biggest points when doing these local server project model round trips is actually the way we do model decomposition in SysML v1. And to those of you who have encountered that, you have noticed that the composition principles in local files and server files, server projects, are completely different. Therefore, it complicates the transformation between the two a lot. It slows things down a lot. Hence, we decided with SysML v2 to start unifying the way we decompose the models. So as shown on the screen, it doesn't matter if you will be modeling on 3D Experience platform, on Teamwork Cloud, or even within the local model repository working on local files, you will have one single node that depicts your model decomposition, a used project node. It will behave very similar between all of these three environments. There will be just some nuances when it comes to versioning, especially between 3D Experience platform and Teamwork Cloud. But no more shared packages, no more mounting points, no more transformations between the two. And I believe it's definitely for the good. Now, talking about inspiration from software engineering, one of the aspects that we were looking into software engineering is how model dependency is being approached there. Modularization in software engineering is nothing new. The problem has been in there, and a solution to that problem, to be honest, for ages. So we started looking into Maven-like dependency management principles applied in software engineering, and we decided that it truly makes sense to start applying similar principles to MBSE, because at the end of the day, we believe that model health in general, when it comes to model decomposition, highly actually relies on how you handle dependencies. So what we learned is that customers usually they don't keep their models in a very healthy state, those models end up with a lot of technical debt, so to speak. Therefore, we decided in SysML v2 models to not even allow you create a cyclical dependency between separate models. In SysML v1 UML-based solution, you were able to do that. You were able to fix that afterwards, but honestly, no one was investing time in fixing that once they have it in place. So from now on, you will not get into a state with cyclic dependencies between models anymore. One other inspiration that we took out from the software engineering discipline is handling conflicting model versions. So in the same Maven system, for example, it's not possible to even have a conflicting module version, right? So that's, again, one of the new ways that we're going to be handling conflicts in SysML v2 as well. Very similar to the cyclic dependency case. It will not be possible to end up in a model state where you have conflicting model versions. One specific model version will need to be defined to be used in the product every single time. Model patching, again, continuing on inspirations from software engineering. So patching is a very well-known term in software engineering. The use case is very simple. You have a very huge code base. You only want to move a small fragment of the changes within the code base between places. So why move the entire code base when you can simply create a patch of a portion of your code and move it elsewhere? Well, this thing did not exist in MBSE, so we were first pretty much to deliver it in SysML v1 solution, and actually this has nice needs and nice use cases in SysML v2. So let's take a look into a very simple example. Let's say we are working on a vehicle system, right? We kind of have the entire design figured out, but we are not sure how the engine aspects of our system would look like, and we would like to pretty much outsource the engine implementation from supplier, possibly even multiple suppliers. So what patching allows us to do, it allows us to take out part of the model, again, not the entire model, but part of the model, and serialize that portion of the model into a physical patch file. Once the patch file is created, you are able to send it to a third party, potentially to a supplier, which is going to be working on an engine implementation. Now, what the supplier does, it pretty much, he augments what you sent to him with implementation details. He defines various attributes of the engine implementation, defines its behaviors, states, internal parts, etc. And what he's done, guess what happened next? Once again, he serializes all of his made changes into a patch file and sends it back to you as an OEM representative, for example. What happens at OEM's side is that you could potentially end up not with one alternative implementation of your engine, but possibly multiple ones that end up being specializations of the engine interface that you sent as a black box to your suppliers, which enables you to choose between the best implementation for your end design. So this is truly groundbreaking. We see a lot of application of the patching mechanism in SysML v1, and we truly think this is going to be groundbreaking for SysML v2 as well. Collaboration. This is the case for internal collaboration, when most of the work happens within the boundaries of one single team. So we actually decided to tackle this with an aggressive strategy. SysML v2 collaboration, at least initially, comes out with lock-free model editing mode only, and there are reasons behind that. So we initially introduced lock-free model editing years ago for SysML v1 solution, and judging by the feedback that we get from our customers, indeed conflicts is something that happens very rarely. Therefore, with the following philosophy, we are going forward in SysML v2. Lock-free model editing works very simply when there are non-conflicting changes made between collaborating people working on the same model. Well, those changes are simply getting merged, as shown at the very bottom. However, in cases when there are conflicts, SysML v2 meta model requires specific rules to handle them. Now, for 26x initial release, we will not have a dedicated fancy UI to show existing conflicts and how they could be solved, but this is something coming in the near future. For now, all of the conflict resolution rules will be the ones as seen on the screen and will be executed automatically by the tool. Now, the API aspects. So both Andrus and Nereus mentioned that SysML v2 comes not only with a meta-model specification, actually two meta-model specifications, SysML v2 and kernel. For the first time in OMG's history, it comes with a separate specification on standard APIs and services. So the goal here is to describe a standard set of services to navigate repositories that host SysML v2 models, not only navigate the repositories, but also navigate the models themselves following multiple navigation patterns. So the specification, for those of you who are not familiar with it, is actually distributed in the following way. So first of all, it's the high-level PIM level definition of services, which are being described in a technology agnostic way, meaning that theoretically any tool vendor can implement API and services with his own chosen technology, which would make him compatible to the spec. Now, down at the hierarchy tree, we can see that there is PSM level. So PSM level is a technology-specific mapping of a specific service defined at the PIM level. So the specification provides two mappings to two underlying technologies. So it's the REST HTTP one and OSLC technology. And obviously, way down at the hierarchy tree, you can see service providers and service consumers. So service providers are tool vendors implementing the API, and the service consumers are the ones using the API. In addition, what we have in the spec is the so-called API cookbooks. So using the API is not a very straightforward thing because it kind of requires you having a prereq knowledge of the SysML v2 meta model as well. Therefore, to ease the process, the specification includes API cookbooks with recipes on how to use this and that service to achieve this and that integration goal. What's our API strategy? Well, standard compliance has been in our DNA, is in our DNA, and will remain in our DNA for ages. Therefore, our strategy is full conformance to the REST HTTP PSN API. You might ask, what about OSLC? Well, in the industry, at least thus far, we don't see much traction for OSLC, but given there's a huge demand, there are valid use cases, we'll definitely consider implementing OSLC PSM as well. Now our goal is to have completely full coverage of the REST HTTP PSM binding. Are we happy with that? Definitely not. We already see opportunities to introduce custom extensions on top. And actually, Nereus showed the very first extension on top of the standard API that we have for SysML v2. It's the model evaluation service. And that's not the last extension, to be honest. We are working on some additional extensions behind the scene. And just, I don't want to unveil those now. Stay tuned and you'll see what other integration scenarios we will enable with our custom extensions on the REST API. Obviously, as we have multiple collaboration platforms, specifically Teamwork Cloud and 3DS platform, our strategy is to have the API support in both. And no, the standalone Teamwork Cloud REST API is not going away. It is not getting replaced with the standard SysML v2 API. The standalone Teamwork Cloud REST API stays here. Not only it stays here, it's going to be enriched with new capabilities. It's going to be made more resilient and to enable pretty much safe model manipulation operations. So we are constantly investing in both the SysML v2 API and Teamwork Cloud REST API, the native one. As you can see on the screen, we have some API documentation fragments of the services implemented. Actually, today we are nearly at 95% of completeness of covering the entire spec. And just to end my presentation, here's a quick teaser showcasing how SysML v2 API works in action. Let's say we have a model of a vehicle, and via the API queries, we want to retrieve the internals of the vehicle only. So what we do is we go to the query service in here. We specify a query that finds a part definition called vehicle, looks for it in a specific package and retrieves its definition with all of the ports included in here as well. So that's what the SysML v2 API queries allow you to do. It's pretty much a way to retrieve model data in a constrained way, not as expressive as the evaluation like querying as Nereus showcased, but hopefully this finds use cases and integration scenarios as well. With that, I think that I'm finished and we'll be open to questions very soon. Thank you.
Okay, thank you guys. Thanks, Andrews, Thomas, and Nerjus for your presentations. Yes, we have questions, and during the session, some answers were given already. So we have now a few questions to answer. So you can choose who is answering the question. So, okay, the first one. What about migration of plugins?
Oh, that's a big one. Yeah, right. Just like I mentioned, as for the language extension mechanisms, they are very different from V1. So likely your plugins are not just, traversing the model and, and doing some kind of analysis. Likely, they also use extensions like stereotypes and profiles. Just like I mentioned, you have to completely rethink the way you did extensions for SysML V1 to actually rebase them on libraries in V2, plus build very light metadatas. And then, yes, you have to refactor your existing plugins significantly and heavily to support SysML V2. And that needs to be planned. That's why part of our strategy is that you do it at your own pace, right? You have to plan which models you are gonna move to V2. You have to plan which plugins you actually need to move to V2. And when you determine which plugins you want to move to V2, you probably want to make sure that you have a thorough review how much of functionality in these plugins you actually need to move to V2. That needs to be planned up front, and then you can migrate, right? So that's a short answer.
Okay, so thanks. I see another question. Is the web view available as part of future implementations of the tool, or is this a feature of the 3D Experience platform?
So there are two questions in one question, I guess. So that's the web viewer that is showed is definitely coming pretty soon, hopefully this year. I cannot promise, of course. And now the second question, is it just on the platform? No, the answer is such that no, it's both available on Teamwork Cloud and the platform on both services.
Okay, thanks a lot. So the other question is, will the specification of a part, action, etc. eventually be structured like current Cameo pop-up window, or will it remain the style used in the refreshed 2 beta V2 version?
Right, it evolved already since then, and we have both the specification window that you were using before, but again, it's an advanced window. What we want to do in SysML V2 implementation is actually to make this nice specification panel that opens on the right-hand side of the screen. That we want to make, to be used by most of users most of the time, like 95% of time users will be using that versus the advanced specification window. But yes, both are supported already in the very latest version. But our focus is on making the specification panel useful for most of the users.
Okay, great. So, okay. So this question, will the changes in TVC shown be only for V2, or will any be added for V1, like lock-free editing local repo?
Yeah, so that is a great question, Randall. So for the lock-free editing, it has been available and will remain to be available in SysML V1 as well. We initially delivered that in, 21x maybe? Now for the local repo, at least for now, it's going to be only SysML V2 specific due to some of the architectural changes that we made in the tool. But the long-term end goal is to unify the entire experience. It doesn't matter, it's SysML V1, V2, to be using and be based on the same concepts. But the initial release, 26x, the local repo notion will be only applicable to SysML V2.
Okay, so do you plan to use the variant management from SysML V2 also in Cameo?
Of course.
Simple and clear. Okay, the other question is, should it be possible to handle SysML files in a Git repo and include them in Cameo via project usages?
So I guess, again, two questions in one question. So one is whether or not you can manage your SysML files in a Git repo. That's even available in today's implementation. We have a way to export files, from Cameo into the file system. So of course you can put them onto the Git. That can be automated again, and we even remember which areas of the model you exported to which files. So yes, this is one thing you can do. Whether or not you want to do it and for what reasons, that's another question. But yes, in principle, that's possible. On another side, whether or not you can use those files, again, files as usages. No, that's not possible today directly unless you automate it somehow. So that you ingest those files as part of the model and then somehow update your project usages. Probably that way you could think of doing it. Yeah.
Yeah, so even this can be, as Andrews mentioned, automated because the standard API, it has services to manipulate used projects. So the concept of used project is also standardized in the API. So theoretically, you can be managing those, creating new projects, changing their versions, passing new payloads with the API in place. Obviously, it only accepts JSON schema-like representation and not textual representation. So you need to do the conversion on your own first.
Okay, so I see that the questions, the numbers are increasing, no matter that we are answering so quickly. Okay, another maybe two questions. Okay, guys, will the client allow a user to commit to a non-TVC service provider?
So directly, no, but again, we are not killing our plugin, development framework. So theoretically, you could come up with something on your own, but just from our experience, it's not enough having only a SysML v2 standard SysML v2 API access at the repository if you want to maintain model, consistency specifically. So fully, out of the box, changing Teamwork Cloud repo to something else only based on the standard APIs, it would be a hard challenge. But theoretically, it's doable with a custom plugin, custom implementation, not something that's going to be available out of the box.
There are some questions where there are 2 or 3 questions in one question. So we will leave these questions to answer our experts in the community under the post. Now, I think the last one is this one. How much learning curve we should expect in mastering SysML v2? Because at our organizations, we are just at the beginning of doing SysML v1. Who can answer this?
Okay, that's another big one, right? Right. So again, it depends on your methodology. So usually, if you are building the right methodology, it should constrain your the number of concepts you are using in the language, right? Independently, whether that's SysML v1 or v2, right? You should never be using entire language. It's like in English, right? Or any language, there are thousands and hundreds of thousands of words, but you're not using everything, right? So your methodology is the key here. So now you have to decide how many concepts you need, right? So the fewer you have, well, the easier it is to learn the language your users are exposed to. Now, so what I believe is that for end users, if your methodology is done right, well, it could be pretty easy. Now, for your experts, they actually need to understand almost most of the language, right? To be able to customize it, to understand which parts of that language you have to use or your users will use. So for your experts, it might be significant investment, right? To learn it. So that's my answer.
Okay, so at least one question, and let's keep it as the last one. How seamless will the exchange of SysML models be with other applications?
The promise of SysML v2 effort in general is increased interoperability, right? So theoretically, it should be seamless, right? But there are challenges that we see depends on what explicitly do you want to exchange. Do you want to only exchange the model aspects of your model and not the visuals, not the diagrams, then yes, you could rely on the standard Exchange file as coming from kernel specification like APAR, which again, theoretically should be implemented exactly the same between tool vendors. But hey, that was the same promise with UML and SysML v1, right? So we already see some potential, challenges in here. Theoretically, it should work again seamlessly. That's the idea, but let's see how it goes.
Yeah, just so you know, again, the truth is that in SysML 2.0, it's not clear how do you exchange diagrams. It's pretty clear how do you exchange models, not diagrams. And that's the focus on 2.1. That's what we are heavily working on internally, and that we'll try to propose how to address it in 2.1. Other than that, I do believe there is a significant potential for anyone learning the language, because the textual syntax is something that you can easily employ in the learning process. You for example, find some examples from books or from somebody else on the web. You just quickly copy and paste the text in our tool, and you go, right, and it just works. So that's kind of an exchange of the models using textual syntax, even if the textual syntax is not meant for the model exchange because it doesn't have the IDs. But in some use cases, that's really useful and great to have.
Okay, so I think that's it with the questions. We still have some of them not answered. So I will add these questions in the MBSE Cyber Systems user community under the post. You can see my screen and you can see the QR code. If in case you are not part of this community, it's external one. It's a very simple registration form. And you can access to some tutorials, you can learn some practices, and also to ask questions and be really part of the really experts and professionals community. So, and I can say that we had a very good webinar thanks to my colleagues, to my friends here in Lithuania, in Kaunas, and all the participants will get the file with the recording. The file will be received through 3D file transfer, so it will be possible to reach 30 days after the webinar. And thanks a lot, everyone, for your patience, for your questions. And we will meet in other webinars. So have a nice day, evening, or day. Okay, thanks a lot. See you. Bye.
Thank you. Goodbye.
Bye.